Okay, when you're trying to figure out if ordered pairs are part of the graph of a given function, these ordered pairs here, like in part A, x is 0, y is 5, I should be able to go back to this linear function, replace x, replace y with those values, and get a true statement back. If I do, then I know that this point is going to lie on that linear function. And if I had to graph this out, I could plot that point, use it to help me graph this line. So let's take 0, let's plug in. If I take 0, plug in, I've got 3 times 0, right? 0 is replacing x. And let's take 5 and plug in. If I take 5 and plug in, that's replacing y. And does that equal 10? That's the question. If I do the calculation here, 3 times 0 is 0, minus 2 times 5, so negative 10. Negative 10 does not equal 10. Therefore, the point 0.05 is not going to be an ordered pair that's on the graph of this given function. This one doesn't work. But try the same thing with 2, negative 2. If I take 2, I plug in for x. I take negative 2, I plug in for y. I've got 3 times 2 minus 2 times negative 2. Does that equal 10? You do the calculations here. You've got 6, and then you've got negative 2 and negative 2, so plus 4. That will equal 10, right? So I could say that this ordered pair, 2, negative 2, definitely lies on the graph of this function. We try 10 and negative 10. This time I replace x with 10, I replace y with negative 10. Got 3 times 10 minus 2 times negative 10. Does that equal 10 overall? Doing those calculations, we see that we get 30. We've got negative 2 times negative 10, we get plus 20. That does not equal 10 overall, right? So this would not be an ordered pair that lies on that function. Okay, if we're going to find intercepts now, given our standard form of ax plus by equals c, what we're going to do, if you consider intercept points, if I consider where the graph of a line would cross the y-axis, well, it's going to cross the y-axis at some y value, but the x value is going to be 0 where it crosses. And vice versa if I consider where it's crossing the x-axis. On the x-axis, it'll cross at some x value. The y value will be 0 wherever it crosses there. So with that in mind, if I'm going to find, say, an x-intercept, to find an x-intercept, I need to let y equal 0. Now, when I let y equal 0, if this is in standard form, that term that has y in it will just drop out, right? This becomes 0, so you have 2x plus 0 equals 8, meaning I can just set up an equation of 2x equals 8. You solve for x, x is 4, meaning your x-intercept, where this line would cross the x-axis at, is the ordered pair 4, 0. X is 4, y is 0. For the y-intercept, again, with what we know about where this line would cross the y-axis, it's going to cross the y-axis at some y value, but x would be 0 where it crosses. So let x equal 0. If you let x equal 0, you plug into this standard form that you have up here. The x term would drop out because this is 0. You'd have 0 plus 3y, which is just 3y, equals 8. Solving for y, we get 8 thirds. 8 thirds, good enough answer here. As long as we put it as an ordered pair, the ordered pair would be 0 and 8 thirds. Now, the nice thing about this intercept idea is, standard form works great for finding intercepts and plotting intercepts if you have to graph the line, but it doesn't have to be in that standard form of ax plus by equals c. Like if you look at part B here, and I'm trying to find the x-intercept, again, to find the x-intercept, I'm letting y be 0, right? So what happens to the y term? The y term will drop out. It will become 0. What would be left as an equation? 2x equals 0. So if I solve for x, x equals 0. Now remember what you did there. You let y be 0. You found that x is 0. So your x-intercept, you got a bunch of zeros there. It's going to be the origin. Now let's go ahead and go through the steps of finding the y-intercept, but hopefully you already know what the y-intercept is. Reviewing those steps to find the y-intercept, we would let x equal 0. If we let x equal 0 up here in our equation, that x term drops out, giving me 0 right here. 0 equals 7y. If you solve for y, divide by 7 to both sides, y is 0. So x is 0, y is 0. How about that? It's the origin again. See, if you find the origin is the intercept for one, it has to be the intercept for the other, right? Our x-intercept and y-intercept are both right there at the origin on this one. So on part C here, say you're going for the x-intercept. We know to find the x-intercept, y would have to be 0. So the y term would drop out when we plug in 0 up here. This is 0 for that y term. 0 would equal -3. Now 0 can't equal -3, meaning we don't have an x-intercept, do we? There's no x left over to solve for. So x-intercept would not exist. Whoops. But on the y side, to find the y-intercept, x is 0, right? So we don't have any x's here, do we? So no x term is going to drop out, meaning we've got 10y equal to -3. If I solve for y, y will equal -3/10. So my y-intercept, x was 0, y is -3/10, which it should make sense here. If I solve for y in the first place, not even worrying about intercepts, what kind of line is this? Special type. It's a horizontal line. It's a horizontal line. It's going to cross the y-axis at that value I got back when I solve for y of -3/10. And since it's horizontal, of course, it's not going to cross the x-axis, so there's no x-intercept. Yeah, that's a special line. Just like part D here, right? Part D is a special line. If you solve this for x right away, x would equal 9/4, right? So when it's x equals just a number, that's a vertical line. If it's a vertical line, then are we going to have an x-intercept? It's a vertical line, we'll have an x-intercept, right? The x-intercept is going to cross the x-axis at this 9/4. So I'd say 9/4 and 0. Are we going to have a y-intercept? Well, the only way it's ever going to cross the y-axis, if this is a vertical line, is if it is the y-axis, right? But this is not the y-axis, so this will never cross the y-axis, meaning there's no y-intercept. If you're asked to find the missing coordinate for an ordered pair given either the x or the y coordinates, this is a lot like what we just did with the intercepts. It's just now we're not dealing with zeros. On this first example here, I'm dealing with an x coordinate of 3. So if x is going to be 3 for this ordered pair I'm trying to find, I'm going to insert 3 in the place of x over here in the equation. So 3 times 3. And I'm going to solve for y to get my missing y coordinate for the ordered pair. Now let's see, we got 9 here. We'd be adding 9 over. So it'd be 18 equals 2y. Divide through by 2. Y equals 9. So I've got my missing y coordinate. And then next example, just vice versa. You know what the y coordinate is. So you take that y value, you insert into your equation over here for y, and we solve for x to get the missing x coordinate. Negative 2x plus 5 times 3 equals 10. 5 times 3, 15. 15 we would subtract over to that 10, meaning we'd have negative 5. Negative 2x equals negative 5. Divide by negative 2, we get positive 5 halves. So missing x coordinate, 5 halves. Essentially the same thing as the intercepts, it's just now we're not dealing specifically with zeros. Now we're getting a good mix here of finding various values for these functions. We've had specific points in x and y intercepts. We've had missing coordinates for ordered pairs. Now we've got one where we know the ordered pair is going to be part of this equation, but we've got to figure out the coefficient here on the x term for this first example. So if I know that this point lies on my function, I know x is 2, y is 8, I just plug in for x and y respectively, and I solve for k. Be k times 2 plus 2 times 8 equals 10. Do a little housekeeping here. We've got 2k plus 16 equals 10. Subtract 16 and 2k equals negative 6. Divide 2, k equals negative 3. So k would have to be negative 3 in order for 2, 8 to be an ordered pair or a point that falls on this linear function. That makes sense. Same idea on the next example. For the next example, we've got a linear function here where we're supposed to have an ordered pair of negative 2, 8 on it. Take negative 2, plug in for x. 3 times negative 2. And take 8, plug in for y. So we've got negative 6 minus 8k equals 15. Add your 6 over. Got negative 8k equals 21. Divide by negative 8. K equals negative 21 over 8, which we can't reduce, so that's what k is.